Hello guys, it is Code for EdTech Challenge by Innomatics Research Labs, and our team has chosen the theme 1 for our proven problem statement. And the theme 1 is about automated OMR evaluation system. As you know that traditionally OMR is to evaluate it consumes a lot of time since it's very easy to mark and calculate, but in abundance of OMR it's very hard, as also they can occur a human error while checking an OMR. So to counter that, we have decided to take on this problem, and here's our web application. This is the first which I ran it. Let me refresh it first. So this is our web application implemented, and it is uploaded on Streamlight application. It is required there only. Uh, Here we have the browse system where we can browse the OMR sheets. So this is currently starting stages, so we have not done anything else. In future we can implement that. We can add the whole folder and it can check the whole of image. So this is one of the sample data, so let's randomly choose one sample data. It is uploaded. As you can see the sample data, you can also preview here, and it is the pre-processed image, how the ML is checking the dots. The bubble dots are calculated through their densities, but the density should be same, so over densitize markings. Like in this row you can see there are two dots which are marked, so the one which is overly marked and not common in area compared to others will be not recorded. And here's the answer which we have gotten here is 26 out of 100, as there are 100 questions and I believe every single one is marked. Let me add one more. Let's randomly do it. Let's say this is uploaded. This is a blurry image and it can still record it, but it's having trouble with recording as it's very blurry and it's in our initial stages. Okay, so here it is, we are getting 11 out of 100.
Hello everyone, presenting a project automated OMR evaluation and scoring system. Checking OMR sheets by hand is a big problem. It takes a lot of time, especially with large group of students, and it is prone to human errors such as misreading or inconsistent marking, and it is difficult to organize and store results efficiently. So our system automates this process using Python and OpenCV. It pre-processes images, detects the filled bubbles, and aligns the sheets. It then compares the detected answers with a predefined answer key. The system automatically calculates per subject and total scores and saves the results for you. The workflow is pretty straightforward. First, you start by uploading the OMR sheet, and then the system previews the sheet and pre-process the image before performing OCR and bubble detection. After that, it maps the answers to correct questions, computes the scores, and displays the results. And then you can download a report. So the system here, as I said, it first cleans up the image through image pre-processing. It uses a technique called offline transform for deskewing and alignment to ensure the sheet is correctly positioned. Noise reduction with Gaussian blur removes scanning noise, and adaptive threshold converts the sheet into a clear black and white image for consistent detection. So next, the system performs ROI extraction. It uses CV counter detection to locate areas like answer regions and alignment markers. This is combined with template matching to ensure the consistent recognition across different sheets of the same design. For bubble detection, the system uses half circle transform To precisely detect the circular bubbles, it determines if a bubble is filled by checking its pixel intensity. So a confidence scoring system is used here to handle cases where students mark lightly flagging uncertain bubbles for review. Then the system moves on to mapping answers. It indexes bubbles with question numbers using a predefined grid and compares them to an easy to update answer key. It also handles multi-choice questions by marking them as invalid if more than one bubble is filled. So finally, during post processing, the system scores the sheet. The score mechanism is configurable with the correct answer being +1 and a wrong one being 0. It flags any uncertain bubbles for manual review to improve accuracy. So results are then stored in a CSV or SQLite database for easy reporting. You can use the system in two ways. There is a command line interface for batch processing of sheets. Alternatively, a Streamlit web apps lets you upload a sheet and get automatic scoring and export the results as a CSV or an Excel SX file. So the web app provides a user-friendly interface for uploading sheets and viewing the results interactively. And the project repository is organized to separate components, data for OMR sheets and answer key, modules for reusable functions, and results for storing outputs. Okay. So the future work for the future, we plan to integrate machine learning to improve bubble detection, especially with noise or misaligned sheets. We also want to support multiple OMR sheet formats to make the system more flexible and develop a cloud deployed dashboard for teachers to view analytics and reports. And yeah, the conclusion for our system is it provides accurate scoring and automates the entire OMR evaluation process. It reduces the time and human errors of manual grading, stores results for easy access, and offers a user-friendly web page. Yep, thank you. That's it.